Okay, so talking about square roots, those are irrational numbers, numbers that cannot be written as a fraction. Basically, how and why do we simplify square roots, and what is the process for computing with square roots? Okay, so here's what a square root is. Let's say we'll take a look at the square root of 49. Well, that equals 7. Okay, that's something you should know. That shouldn't have surprised any of you. Okay, right here, this is called our radical symbol. Right? We talk about square roots as they fit with the radicals. And this is the radical symbol. Later on in the year, we'll talk about numbers that we take the cubed root of and whatnot. But for now, just square roots. 49 is the radicand. The radicand. Okay, that's the number we're taking the square root of. 7 is the principal root. Principal because it's positive. So this is the principal root. Principal because positive. Every number technically has 2 square roots. Okay? Let's take a look at 17, or it's not 17, excuse me, 16. The positive square root of 16 is 4. The negative square root of 16 is negative 4. Plus or minus the square root of 16 is a plus or minus 4. Okay, so every square root has 2 answers. We can almost think about it in 3 different ways: positive, negative, or plus or minus. Okay? Something you should know. You should know your perfect squares. You should know what those are. They will help you for everything that we do next. 1, 4, 9, 16, 25, 36, 49, 64. Oops, I wrote that backwards. 81, 100, 121, 144, 169, 196, 225. I think you should know the first 15. Probably the first 16, because 16 is 256. But anyway, you should know these. They will help you for what we do next, which is simplifying, or how to simplify square roots. Okay, there is a process for how to simplify square roots. We simplify square roots because it helps us look at them a little bit easier. There are pros and cons to doing it, but it basically makes them easier to talk about a little bit. Okay? Let's look at an example and then kind of talk through the steps as we look at the example. Let us simplify the square root of 90. Okay, we're going to simplify the square root of 90. We have to first of all split it into 2 parts. Okay, so the first thing we're going to do is split it into 2 smaller square roots. Basically what we're doing, the first thing we do is split it. We split it into a perfect square factor, and then what that number is multiplied by. So we have a perfect square going in the first box. Well, in the case of 90, a perfect square that goes into 90 is 9. Okay? Well, to get 90, you take 9 times 10. So then 10 goes in the part that tells us what we multiplied. The easiest way to do this is to find the biggest perfect square that divides the number you are simplifying. That will make it easier if you can find the biggest perfect square. Okay? Step 2, we're going to take the square root. You got the square root of 9 sitting there, you know it's 3. The square root of 10 should stay. The last thing you're going to do is you're going to check. Check your answer. What I mean by that is that 10 able to be simplified further? If we would have ended up with like 40 instead of 10, well then we can simplify 40 because 4, a perfect square, goes into 40. What you need to ask yourself, Is there another perfect square? See, perfect square in the radicand. Is there another perfect square that is in your radicand? If there is, you are not done. Okay? Let's look at another one. Square root of 162. That's a big one. Okay? A perfect square that goes into 162. If you know your perfect squares, you can just run down the list. 162 is bigger than 144. Well, 144 does not divide into 162. 121 does not divide into 162. 100 does not divide into 162. When you split these up, the first perfect square, the biggest perfect square that goes into 162, well, that's 81. 81 goes into 162. To figure out what goes here, we can do 162 divided by 81. So since that's 2, 2 goes in that second radical. Then, step 2, take the square root. Well, the square root of 81 is 9. Square root of 2 just comes down. Check it. Is there any perfect square that goes in the square root of 2? Okay, I can hear some of you saying yes, 1. I don't care about 1. 1 sucks. Okay? Square root of 2. Okay, I got 2 more for you to try. Square root of 72 and the square root of 200. Okay, push pause and give them a try. Okay, check your work. How'd you do? Did you get 6 square root of 2? 36. Goes into 72. 36 goes into 72. Gives us 2. 36 and 2 fill our radical houses, essentially. 1's a perfect square, 1 is not. Same thing with 100 and 2 down in the bottom. 100 is a perfect square that goes into 200. 2 is what's left over. 200 divided by 100. Once we pull that 100 out, divide it out, that leaves us with 2. Now, these are all the same because they were 2's. That just happened that way. But that's simplifying square roots. That's one thing, one operation, one calculation we do with square roots. The next one is how to rationalize the denominator. Denominator, of course, is the bottom of a fraction. You should know that. So here's how we rationalize the denominator. We multiply the denominator by a number which will produce a perfect square. That is a lot of words. Let's talk about what it looks like. Multiply the denominator to make a perfect square. We never want a radical in the denominator. And that's the goal. No radicals in the denominator. Bad news if you have that. Okay? Here's an example. 1 over the square root of 8. We see the 8 under the square root in the denominator, bad news. Okay? Here's what we're going to do. We want to make a perfect square in that denominator. What is a perfect square that 8 goes into? Well, 8 goes into 16. So we can change the bottom to be a perfect square. Okay? 8 also, when you multiply it by itself, makes 64. So I'm going to show you 2 ways to do this one. Okay? Let's first look at changing this to be the square root of 64. We're going to multiply the top and the bottom by the square root of 8. When we do that, in the numerator, we get the square root of 8. In the denominator, we get the square root of 64. 8 times 8 is 64. Well, the square root of 64 is 8. Woohoo! But the square root of 8 can be simplified. Just like we just did, we can break it up as 4 times 2, which becomes 2 square roots of 2 over 8. Because the square root of 4 is 2, which which that becomes 1/4. Okay? That's a long process, but you'll figure it out. I know you will. Okay. There's a way to get to the answer a little faster. This is using 64 as the perfect square in the denominator. Down here, we're going to use 16. To take 8 and make 16, we multiply by the square root of 2. We multiply it in the denominator, we multiply in the numerator, that's going to be our process. Okay? That means we have the square root of 2 in the numerator, and the 8 times 2 being 16 gives us the square root of 16 in the denominator. That's the perfect square we made. We are always making perfect squares. Okay? Square root of 16 is 4. The square root of 2 cannot be simplified. We got the same answers. Just got to them a little bit differently each time. That's okay. They're the same, just a matter of how you get there. We didn't have to reduce in the bottom one. There was no, we had to, up here in the top one, we had to simplify the square root of 8. Not a bad thing, it's just something we had to do. Okay, I'm gonna give you 3 to try. Now I know this is tricky, we will continue to practice this. Here are 3 that I would like you to try. Oops. 3 over the square root of 7. 5 over the square root of 10. And 1 over the square root of 3. Okay? 3 over the square root of 7, 5 over the square root of 10, 1 over the square root of 3. Okay? Pause it. You give them your best shot. Check your work. Square root of 7 over square root of 7 in the first one, making the square root of 49. 49 is the perfect square we were making in the denominator. Here the perfect square we made is 100, 10 times 10. And down here we made the perfect square 9 by doing the square root of 3 times the square root of 3, which gives you final answers of 3 times the square root of 7 over 7, 1 times the square root of 10 over 2, square root of 3 over 3. Okay? That is rationalizing the denominator. Tricky stuff we will continue to practice. Last thing. Computing with square roots. How do we add and subtract? In order to do that, we need to know what we have for what are like radicals versus unlike radicals. Okay, what are like radicals versus what are unlike radicals? Here's what it takes to be like radicals. They must have the same radicand. Now, if you think back, that would be the number under the square root. That must be identical. And that's what you need to be able to add or subtract. Okay? That's the only way you can add or subtract. Here's what you do. If you don't have it, the first thing you have to do is simplify. You may need to simplify your square root. Then you combine your like radical terms by adding or subtracting their coefficients, the numbers that are not in the square root. Okay? Here is an example for you. Here is an example. 5 times the square root of 3 plus the square root of 12. To make this work, we have to simplify the square root of 12. Well, the square root of 12 splits into the square root of 4 and the square root of 3. The square root of 4 is 2. The square root of 3 just stays. Now we add coefficients 5 and 2 and get 7 square roots of 3. That is how those two are added together. We cannot add them until we have like radical terms. And we have like radical terms when those are both 3. So lots of things with square roots, lots of things for us still to practice.